The moment you finish your last bite, a countdown begins. Not toward starvation. Toward transition. Most people never experience this shift because food keeps arriving: breakfast, snacks, lunch, coffee, dinner. Imagine a factory where deliveries never stop. Workers are constantly sorting, storing, and stacking boxes. There's no time for maintenance. No time for repairs. Just non-stop processing. That factory is your metabolism on constant meals. Now imagine the deliveries pause. For the first time, the system can breathe. Hour 0 to 4, the fed state. During the first few hours after eating, your body is busy. Carbohydrates break down into glucose. Proteins split into amino acids. Fats are packaged and transported. Blood sugar rises, and your pancreas releases insulin. Insulin is not bad. It's necessary. But it has one clear instruction. Store energy. While insulin is elevated, your body prioritizes using incoming fuel. Any extra glucose gets stored as glycogen in the liver and muscles. Glycogen is your short-term savings account, quick to access, but limited. During this window, fat burning is minimal. Not because your body is broken, but because it's logical. Why burn stored fuel when fresh energy is abundant? Nothing dramatic happens yet. You feel normal. Satisfied. Stable. But under the surface, a clock is ticking. Hour 4 to 8, insulin begins to fall. As digestion slows, blood sugar stabilizes. Insulin gradually declines. The immediate fuel from your meal is mostly handled. This is where many people misinterpret signals. Around hour 6 or 7, hunger can rise. Ghrelin, the hunger hormone, increases. You might feel a wave of irritability or a drop in focus. This isn't starvation. It's a fuel transition. Your body has been running primarily on glucose. Now it's being asked to shift gears. And like any engine switching systems, there can be a slight stutter. If you eat here, the cycle resets. But if you don't, your body does something fascinating. It reaches into glycogen stores, that short-term energy reserve, and begins releasing glucose steadily to keep your brain and muscle supplied. You are not breaking down muscle. You are not shutting down. You are simply using stored fuel exactly as designed. And this is only the beginning. Because once glycogen runs low, your metabolism makes a decision that most modern humans rarely allow it to make. In part 2, we cross the 12-hour mark, where fat burning truly accelerates and your body unlocks a deeper energy system most people never tap into. By the time you reach hour 10 to 12, something significant is happening. Your glycogen stores, that short-term wallet of energy, are running low. This is a metabolic crossroads. Your body has two choices. Conserve energy aggressively. Or access a more powerful reserve. In healthy individuals, it chooses the second option. Hour 12, insulin at baseline. By this point, insulin levels are near baseline. This matters because insulin acts like a gatekeeper. When it's elevated, stored fat remains largely inaccessible. When it drops, that restriction loosens. Now an enzyme called hormone-sensitive lipase becomes more active. Its job? Break down stored fat into fatty acids so they can be used for energy. This is where real fat utilization begins to increase. You're no longer running primarily on yesterday's sandwich. You're running on stored body fat. And here's something important, this process is gradual and regulated. Your body doesn't panic. It doesn't cannibalize muscle immediately. It shifts fuel sources. Hour 14 to 16, the fuel upgrade. As fatty acids are released, the liver converts some of them into molecules called ketones. Ketones are an alternative fuel source, especially useful for the brain. Your brain cannot directly burn fat, but it can use ketones efficiently. Many people report that around this window, 14 to 16 hours, mental clarity improves. Not because of magic. Not because fasting is mystical. But because fuel becomes stable. When eating frequently, blood sugar rises and falls repeatedly. That can create energy swings. When relying more on stored fat and ketones, energy delivery becomes steadier. From an evolutionary standpoint, this makes sense. If humans became mentally foggy every time food wasn't available, survival would have been difficult. Instead, the body evolved mechanisms to stay alert during short periods without food. However, this is also where adaptation matters. If someone jumps directly into long fasts without preparation, this transition can feel uncomfortable, headaches, fatigue, mood shifts. Often, that's related to electrolyte changes and metabolic inflexibility. Which raises an important question. What happens if you extend the fast beyond 16 hours? Because now we move beyond fuel switching, and into cellular housekeeping. In Part 3, we explore what researchers call autophagy, the internal recycling process that begins to rise as fasting continues. And this is where things get truly interesting. By hour 16 to 18, your metabolism has largely shifted into fat-dominant energy production. But energy isn't the only thing changing. Inside your cells, a quieter process may be increasing, one that scientists have studied intensely over the last 2 decades. It's called autophagy. The word literally means self-eating, but that phrase can be misleading. It's not self-destruction. It's self-recycling. Think of your cells like busy workshops. Over time, damaged proteins accumulate. Old mitochondria, the tiny energy producers, become less efficient. Misfolded cellular components build up. When nutrients are constantly abundant, the body prioritizes growth and storage. But when nutrient signaling drops, particularly insulin and mTOR activity, the body shifts toward maintenance. During extended fasting windows, autophagy activity appears to increase in many tissues, based largely on animal and early human research. The cell begins identifying dysfunctional components, surrounding them with a membrane, breaking them down, and reusing the raw materials. It's a cleanup and renewal system. Now, to be clear, autophagy is complex. It doesn't suddenly turn on at a precise hour like flipping a light switch. It likely rises gradually depending on individual factors, metabolic health, prior diet, activity level, and genetics. But extended fasting periods may encourage this maintenance mode more than constant feeding does. Why does that matter? Because cellular maintenance is tied to healthy aging, metabolic function, and resilience. Again, this doesn't mean fasting is a miracle cure. It means your body has built-in repair systems, and periods without food may give those systems space to operate. As you approach hour 18 to 20, another shift occurs. Counterregulatory hormones begin adjusting. And one in particular plays a protective role. In Part 4, we address one of the biggest fears people have about longer fasting windows. Won't I lose muscle? The answer is more nuanced, and more interesting than most people expect. One of the most common concerns about longer fasting windows is muscle loss. It's a valid question. Your body does require amino acids. And in extreme starvation, muscle breakdown does occur. But short-term fasting in healthy adults behaves differently. As fasting extends past 20 hours, growth hormone secretion tends to increase. Studies have shown that fasting can significantly elevate human growth hormone, HGH, levels. Why? Growth hormone helps preserve lean tissue and supports fat mobilization. In simple terms, it encourages the body to use fat while helping protect muscle during short periods without food. This doesn't mean muscle is completely untouched, metabolism is dynamic. But in healthy individuals who consume adequate protein during feeding windows, muscle loss during controlled fasting is generally limited. Another important shift occurs at this stage. Insulin sensitivity improves. After many hours without incoming calories, cells become more responsive to insulin. Think of it like a sponge that has dried out. When nutrients finally arrive, the body is primed to absorb them efficiently. That's one reason what you eat to break the fast matters significantly. If you end a long fast with a large load of refined sugar and ultra-processed food, you can trigger a rapid blood sugar spike and an exaggerated insulin response. That often leads to fatigue and bloating. But if you break the fast strategically, starting with high-quality protein, adding healthy fats, and including fiber-rich vegetables, you support muscle repair, stable energy, and micronutrient replenishment. This is not about earning junk food. It's about using the metabolic state wisely. And now we reach the final piece of the puzzle. Adaptation. Because none of this works well if you shock the system. In Part 5, we talk about how to transition safely, who should avoid extended fasting, and how to build metabolic flexibility without burning out your hormones. If someone goes from constant grazing to a 23-hour fast overnight, it often feels terrible. Headaches, fatigue, irritability, poor workouts. That doesn't necessarily mean fasting doesn't work. It often means the body hasn't developed metabolic flexibility, the ability to switch efficiently between glucose and fat for fuel. Like training a muscle, this shift takes time. A smarter approach is gradual compression of the eating window. Delay breakfast by 1 hour. Then 2. Eventually try a 14-hour fasting window. Then 16. Allow your enzymes and mitochondria to adapt. Another common issue during early fasting attempts is electrolytes. When insulin drops, the kidneys release more sodium and water. That can lead to headaches or dizziness. Replenishing sodium, often with a small amount of salt in water, can reduce these symptoms. But fasting is not appropriate for everyone. It should be avoided or medically supervised in individuals who are pregnant or breastfeeding, underweight or with a history of eating disorders, taking insulin or certain diabetes medications, managing blood pressure medications, experiencing chronic high stress or poor sleep. Fasting is a stressor. In a well-recovered body, short-term stress can be beneficial. In an already overwhelmed system, it may worsen cortisol imbalance. The goal is not punishment. The goal is metabolic resilience. In a world of constant food availability, structured fasting reintroduces rhythm. Fuel. Use. Repair. Repeat. You are not starving during a controlled fast. You are allowing stored energy to be used, insulin to fall, cellular maintenance to increase, and sensitivity to reset. But the real power isn't in the hours. It's in the consistency. So here's the final question. If your body has this built-in system for switching fuels and repairing itself, are you giving it the space to use it? And if you decide to try, will you stop at the first wave of hunger, or push through to see what your metabolism is truly capable of? Let me know which hour feels hardest for you. Because the transition point is where the transformation begins. Here is a stronger, more engaging last message, outro, you can use at the end of the video. So now you understand something most people never do. Hunger is not an emergency. It's a signal. And signals can be managed. Your body isn't fragile. It's adaptive. It was designed to switch fuels. It was designed to repair. It was designed to survive periods without constant food. OMAD isn't about punishment. It's about giving your metabolism space to work the way it was built to. But here's the real question. Will you trust the process long enough to experience the shift? Will you stop at the first wave of discomfort? Or will you push through to hour 16, hour 18, and see what changes? If you try this, comment below. Backhand index pointing right. What hour feels hardest for you? Backhand index pointing right. When do you feel the mental clarity kick in? And if this breakdown helped you understand your body better, subscribe, because the more you understand your biology, the more control you gain over your health. I'll see you in the next one.